How's the sound?
Melodious.
Well, I got to change the setting over here, and I think you're being too kind. Yeah, okay, I'm not getting any feedback from YouTube anymore. All right.
So Dave and Steve, the presentation is just a video that I did, and I'll give it a little introduction and then answer questions at the end.
Yeah,
So,
you have to set the audio feed separately for that. You've done that before?
No.
Okay. It when you go to
Hmm.
share screen, there's two check boxes at the bottom. One is share sound, which you have to click, and the other is optimized for video clip, which I
Oh, I see
believe,
him.
yeah. So that's and then you need to have your video ready and full screen on one of
Yep.
your screens, and that makes it difficult to get back to the Zoom screen, but I use the Alt tab for that, and it seems to work fine.
Okay.
hey, Mike.
Yes, sir.
Um, Robert asked about viewership on the newsletter.
Hmm.
I finally figured out how to use Google Analytics, and it shows we've had 102 views.
That's like about half the membership, so that's pretty good.
Yeah, yeah, right. And I think that's over the last month.
Yeah, that's what I was wondering.
Does the Google Analytics show um, uh, how many times the newsletter was viewed, or how many unique IP addresses, how many unique people viewed it? If you're talking, Steve, I'm not sure, but your microphone is off.
Yeah, let's see what else. I'm not very good at using this yet.
Yeah.
I haven't used it in years. Um, it was, find it again, the 37th most popular um, page on the site. I guess I don't know what this means. I'll have to research it and I'll send you a report. Well, I'll wait a couple more minutes before we start. We don't have much attendance tonight. But that's the way it goes.
Well, we've got 9 more on YouTube. So anytime you'd like to go, Steve, I think we're
Let's go ahead and get started. Welcome everybody to the September meeting of the Early Television Museum community. Thanks all of you for attending. Tonight we're going to have a presentation by Mike Molnar that's not about early television sets, but Mike, as you guys probably know, collects all kinds of old things. And so he volunteered to give a short presentation about old electric meters, which I know nothing about, and I'd be fascinated to hear it. So to start out with Dave, give us the courtesy announcement.
Yeah, just the usual. Please try to remember to keep your microphones on mute unless you're actively part of a discussion. That helps keep the chaos down. That is all.
Thank you. I want to thank the New Jersey Antique Radio Club for sponsoring this meeting and providing our Zoom feed. We greatly appreciate it. Give you a brief report on the museum. No new members. We're still at 207, which I mentioned last time is substantially above last.
Steve,
Yeah.
we actually did. I'm sorry, I got to send you the information. We did have a lady sign up for a membership.
Good.
So
Yeah,
I'll need to send you that.
Good.
I'll send you that.
Good. We're starting to get people signing up for membership when they come visit the museum, which is really nice. The two things we've got coming up in the near future are the swap meet on the 12th. Blake Hinkle is managing that. I will be there. I'm coming back to Columbus tomorrow, so I'll be around for that. We're going to have the drawing for the sweepstakes prize. 2 o'clock in the afternoon that day. I am much more optimistic about what we're going to get on the sweepstakes. We're above $9,000 now, and we've got a week to go, and the last week is always a big week. So I wouldn't be surprised if we hit 11, which is the ballpark of what we've had in the last 2 years. So if you haven't bought your tickets, get them. I'll get them online right now for a couple more days. There's a bonus. You get 50% bonus tickets. So if you haven't bought any, do it. If you have, buy some more. All the proceeds go to support the museum. That's why it's one of our major fundraising events of the year. That's about all I have got. Is there anybody who is new to this meeting that would like to introduce themselves? Well, I guess not. Let's go on to my presentation of an item that we have in the museum. This month, I'm going to talk about the oldest electronic set we have in the collection, and that's the Kosser 137T. It was made in 1936. It's a British set, and it is it's really primitive. It has a 14-inch electrostatic deflection tube in it. I'll show you when we go in the next room. I'll show you what the tube looks like, but it's got an AM shortwave radio. It's tuned RF like almost all of the British sets were at the time. We have restored this set. It's in great shape. We restored it. Unfortunately, the CRT had an open filament, but I was able to buy some radar tubes from England that are the same physical size and put one in. Now, obviously, so the picture looks pretty good when it's a still subject, but if it's a moving image, it's not. It's a P7 phosphor, so you get the the blue short persistence and the yellow long persistence, which makes it sort of hard to watch. But we just thought it'd be fun to have it working. Now this set, as I said, it was the among the first of the British sets, 1936. The 37 is when the more popular sets like the HMV and Marconi sets came out, and their technology is still sort of primitive, but nothing like this thing. Anyway, Larry, why don't you go in the other room and I'll tell you the next part of the story. And that involves Dumont. When Dumont first started selling sets before the war, they sold rebranded Kosser sets. They had, I don't know if they just stole the technology or if they had an agreement with them, but the CRT is very, very similar. You can see what it looks like. It's a monster. Electrostatic deflection. It has a 1500 volt power supply for the deflection plates, and then an $8,000 volt negative and positive voltages for the CRT, and it produces a pretty decent bright picture. And this set is very similar to the Kosser, except that it uses American tubes rather than the British equivalent. But after the very beginning, Dumont developed their own set. This is the 182, I think. They developed a line of 12-inch, 14-inch sets, excuse me, the largest pre-war sets. They also had a 20-inch model, also electrostatic deflection. None of those survived that I know of, but never found any information on what their arrangement with Kosser was. But they obviously copied the technology and really Dumont didn't change. All their pre-war sets were the same design. It wasn't until after the war that they went to a different technology. The other difference about the Dumont is that it had a 5-channel tuner, because in the US we had more than one station before the war. So that's it. Any questions or comments?
Yes, I have one. Is that the oldest working electronic television in the US? Are there? What's the story on that?
I think it is the oldest working one. I don't know of any, because the only set that is of this era that is in the US, I don't know if there are any of these in the US other than ours. Now, there are plenty of these, there are lots of the Dumont sets, but there are, that they date from 1930, late 38 and 1939. So they're a few years later. But I don't know of any Kosser 1936 models that are in the US. So I think it is the oldest working electronic set in the country.
Steve, I had read about Dumont making a trip to Kosser when he was gearing up to go into TV production. So unless he wasn't invited and was just sneaking in the windows, he probably did have some agreement with them.
That makes sense. Any other comments or questions?
Yes, again, I have one other question about the Colster Brandeis. Where did you get that?
There was when I first started the museum, I wanted to get a representative sample of British sets, and there was a collector over there who since died. He was a major. He had by far the biggest collection of pre-war sets in England, and he had duplicates of a number of sets, and I bought some from him, and I think that's where I got it. Any more comments or questions? Let me mention something that came from our last board meeting that we had, and talking to the other board members, and particularly Chuck Conrad from the Texas Broadcast Museum. We're discussing the problem of keeping the rare sets, especially the pre-war sets and the early color sets, keeping them running so that we could show them to the public. And we came across the idea of doing a short video loop in each area: mechanical, British pre-war, American pre-war, early color, that features screenshots of all of the working sets that we've got. Some of them we only fire up occasionally, like the one we were just talking about, and capture them all on videotape and produce a loop that we would show on a small screen in each area, so that people could see what the picture looked like without us actually having to turn on the set and you know, hasten their failing, because that's what they do. They do nothing but fail. So I'm gonna implement, if they start doing that, as soon as I get back to Columbus. It's one of the things on my agenda for while I'm in town. So that'll allow people to see what the pictures look like on the mechanical sets, which we only fire up, you know, at the convention, basically, and all those other rare sets too. Any other comments, questions? Well, then I'll turn it over to Mike.
Okay. And I'm going to give this Dave tells me it's a little tricky to run a video clip, but we'll see how this goes. The reason I did this presentation a few years ago is during the pandemic, and there was a group that couldn't get together, so I made a little video of some early electrical meters. And just a little background, the reason I got interested in them was from a couple of things I had read in books, one by Francis Jail, who was an early employee of Edison's in Menlo Park. And he was asked how they were able to measure different things and during experiments on the light bulb. And he said, even though they knew about things like Ohm's law, they never really applied it to any great extent, because they didn't have meters to really measure things. So when they had to find out how competitive the electric light would be, they did it in pounds of coal that were needed to run the steam generator, to run the electric generator, and produce the electricity for X amount of hours and X amount of bulbs. So I figured, well, then somebody must have been working on meters a little after that. And one of the people that did a lot of development and had the Weston company, Edward Weston, started, and he had been an early light bulb experimenter, and he had a arc lighting business and made generators. And when he was taking his equipment to a demonstration at the Franklin Institute, like a convention, and they set up a display of his equipment. To prove his stats on his equipment took a full week of setting up delicate instruments to finally figure out if he was able to produce the voltage and current and different ratings of the equipment that he was presenting. So the more I dug into this, a few interesting old pieces came my way, and when I was asked to do this presentation, this is what I came up with. So it runs about 12 minutes, and I'll be happy to answer any questions after that. So let's see if I can do share and screen 2. And these two I've got to collect here. And if somebody could tell me if this is going to come through.
We're still seeing you.
Okay, so I did. Oh, I have to click share one more time.
There we go.
This is a Lord Kelvin's electrostatic voltmeter.
It's
Get
not,
in volume.
Not full screen, volume is low.
It was built by the Kelvin and James
Okay.
White Company of Glasgow and London and dates to the 1890s.
I'll back up to
Mhm.
make it better.
Its operation is based on the principle that two conductors that take for granted today.
This better?
It
This
is,
a
it's
Lord
still not
Kelvin
full screen.
electrostatic voltmeter.
Still not full screen.
It was built by the Kelvin and James White Company of
It's
Glasgow and London.
it's full screen
and
on
dates to the
mine. Can you give me any
1890s.
clue of what to look at?
Its operation is based on the principle that two conductors at different potentials.
Now, Mike, you're sharing your full screen. You should be sharing the window that has the movie in it.
Okay. Let's see if I move the movie down to this other screen and see what we get. This is going to be better?
No, that's proving that you are sharing your full screen.
Okay. Let me go back and hit share again and see what I come up with. You are screen sharing, share. So
Mike, look for share application and share whatever app you were presenting that in. And your screen is full, but the app isn't filling it out. It's gray barn on the sides.
okay.
The outline of your
If-
app.
Yeah, if this is what you're talking about, this is the size that some of the pictures are.
And Mike, you're going to have to stop the sharing and start it over
You
again.
got to drop the share and restart it,
Okay, so I've stopped. And
and see if you can share the application as opposed to the screen, and that might improve things a bit.
media player?
Yeah, I think that's what you were using.
No, I was on what said screen 2 on mine. Let's see what this does. Is that showing up?
Yeah, it's probably as big as it's going to get, I guess.
Okay. Well, sorry about that. I'll have to kick it back here and start again.
Take for granted today. This is a Lord Kelvin's electrostatic voltmeter. It was built by the Kelvin and James White Company of Glasgow and London and dates to the 1890s. Its operation is based on the principle that two conductors at different potentials attract one another. In this case, the first conductor consists of the two brass-colored plates that are in a fixed position. The second conductor is silver-colored and can rotate on a center shaft. It has an indicator attached at the top, and it is kept in position by gravity and balanced with weights that are placed at the bottom of the conductor. When a potential is applied to the conductor, the movable conductor is drawn towards the fixed conductor, and that draw is strong enough to overcome gravity and the balanced weights. As the indicator moves up the scale, a reading is then taken. That reading is multiplied by the number on the chart based on which of the weights is in place. We can see that a full scale reading of 60 and the highest multiplier of 200 would give a full scale reading of 12,000 volts on this meter. This device doesn't look like an electric meter at all. A tabletop unit, it weighs in at 60 pounds. It is a Lord Kelvin electric balance built by James White in Glasgow and measures electrical current, also dated from the 1890s. Current is applied through the copper connections at the rear of the meter. The coils and discs are actually on opposite sides of a balanced beam. The heavy coils are wound such that on applying a current, the magnetic field pushes one disc up and pulls the other down. As the weight shifts, the operator can move weights along the front scale as you would on the old scale in a doctor's office. When balanced, the weights have a multiplier value times the number on the scale. This highest scale is around 60 amps. It certainly gives the illusion that you are weighing the electricity. And now we'll take a look at a simple voltmeter from the late 1800s made by K&D. It has a handwritten scale going up to 21 volts. It has a coil wound on a wooden frame with a pin set through it at the top. A small magnet is attached to the pin, and the indicator is attached to the magnet. The magnet and indicator are balanced so that the position is at 0 when no voltage is applied. To act as a voltmeter, the voltage is applied to a positive terminal and into the coil, then exits the coil and into a fixed resistance, then to the minus terminal. When a voltage is applied to the coil, it produces a magnetic field strong enough to overcome the force of gravity and deflects the magnet and indicator in a way that's proportional to the voltage that was applied. Next is a Thomson and Rice ammeter, which dates to around 1888. Ammeters can be recognized by their coils having heavier gauge wire and are wound with less turns. They in turn deflect an indicator in this meter across the top, which moves along that darkened scale. Thomson on the tag is inventor Elihu Thomson from the Thomson and Houston Company that became part of General Electric. The name Rice is for E.W. Rice, an inventor who worked with Thomson and many others. At the bottom of the meter near the terminals, we can see an open switch, which is there to allow changes in the range of operation. This small DC voltmeter was made in Paris and has a scale of 1 to 12. The distance between dial marks tells us that the response of the meter is not linear, and it gets its accuracy by the calibration of that dial at the factory. It's a small meter and is just about 4 inches in diameter. This beautifully crafted meter comes with its own carrying case. It was manufactured by the James W. Queen Company of Philadelphia. From the second half of the 19th century, the company produced scientific equipment, astronomical equipment, and surveying equipment, all of a high quality. The dial, uniformly marked from 0 to 100, hints that the meter was not for 0 to 100 volts, but rather the operator would multiply the reading on the meter times some number on a calibration chart, a chart that was likely attached to the inside cover of the box. For example, a reading of 20 may have had a calibration factor of 5, so that the actual voltage reading would be 10 volts. The internal construction has a moving coil and 2 permanent magnets. From the side, we see that there is a removable section at the bottom. This section, when attached, extends the operating range of the meter. It puts 4,000 ohms in series with the meter itself, which is labeled to be at 1975 ohms. This early meter is not marked with the manufacturer's name. That's unusual for something that was so well made. On the simple 0 to 5 volt scale, there is an unusual second piece on the dial. This brass-colored arm can be positioned by turning the knob at the front. It could have been used to set a maximum reading, or to steady the indicator, or to lock down the indicator for transport. This meter was produced in London and is labeled Becker and Hatton Wall. I selected it because of an unusual feature in an early meter. This view shows a coiled spring providing the resistance that zeroes the meter, something usually found only on later meters. Also, there are 2 scales, one in red and one in black, and both are labeled from 0 to 10. This might imply 2 ranges for the meter that could be selected by a shorting pin going into the brass connections on the side. I don't have any documentation on this, but it could be that one pin meant reading voltage on one of the scales, and another pin in the other side could have meant reading current on the other colored scale. This unusual device is an Edison pressure indicator. It was used in power stations and is described in the book Dynamo Tender's Handbook, written in 1892. It was known that varying the dynamo outputs would shorten the life of the incandescent lamps of the power station's customers. This device could regulate the pressure, now called voltage, coming from the dynamos. It utilized a lamp in a Wheatstone bridge circuit and a galvanometer that would allow the operator to balance the voltages. This is a Westinghouse AC ammeter. Its components are mounted to a heavy rectangle of marble, and the components are also shielded from any air currents by the glass case. This meter likely dates from the late 1890s. Westinghouse had won the Battle of the Currents, and the number of AC installations was on the rise. When mounted on a wall, the plumb bob on the right side is used to assure the meter is level both left to right and front to back. At top center, a shaft holds the indicator arm and is the pivot point for an iron rod and a balance weight. The balance would be adjusted to zero the pointer. When current passes through the coil, the iron is drawn down, deflecting the indicator. Full scale on this meter is 60 amps AC. This meter was made by the Victor Electric Company in Chicago, no relation to the Victor Phonograph Company. This is an example of some meters made for or by companies working in electrotherapy and X-ray. Victor is one of these companies, started in 1893, and it became part of the Victor X-ray Company, a division of General Electric, in 1920. Another example is this Macintosh meter. Macintosh also a company that was building electrotherapy equipment. This is one of their devices. You can see a meter at the top, built for electrotherapy, and it's called the polysine, which had an output of various formations of sine waves. This is an early ohm meter by the Waite and Bartlett Company, another electrotherapy and X-ray company. This Waite and Bartlett milliamp meter shows the company's New York address. From that location, they made many types of medical equipment. Their products included this large Holtz machine capable of producing tens of thousands of volts to perform electrotherapy treatments and to power early X-ray tubes. This early meter was produced by the Weston Company, started by Edward Weston. It marks the beginning of what we recognize as early 20th century meters. His goal was to make meters that were direct reading, meaning a dial reading would not require calibrations or calculations from a table. Striving for perfection, Weston included a mercury thermometer you can see on the upper right side, and a dial to compensate for matching the room temperature to the meter. With further development, he produced the Model 1. It included improved shunts, a moving coil with a permanent magnet, and a coil spring with a jeweled movement. It can be confusing to study these meters, as all of these are Model 1s. The Model 1 was produced for decades. The buyer would specify what he needed the meter to measure. Weston also provided large power station style meters for companies all around the world. Weston still produced meters into the digital age. The top meter works with a small LED display, and the bottom meter used Nixie tubes. That's the end, so thanks for watching this presentation. I don't promote myself as an expert on this equipment, so I would be interested in anyone's comments or further information, and I would like to get an email at mmolnar@diagnostic-services-inc.com. Thanks again.
That scary picture, if it's coming in, is my dog. If anybody has any questions, I'll see if I can get back to my normal screen.
You're there.
Okay. And I apologize for the small screen. I tried a number of different things, but it's the first time I sent out a video this way.
Well, as you know, Mike, this is a very loosey-goosey meeting. And we expect experimentation and things not going exactly the way you want them to go. It's part of the game.
Well, I'm kind of sorry that Wayton Bartlett Holtz machine didn't show how big it really is, because it's the size of 2 refrigerators next to each other. And it's been a resident here at the house for many years. We don't want to be able to move it without a trucking company.
I'm sure that's one of your wife's favorites.
Yeah, we call it Sparky, and it doesn't eat much, and the cat likes to live under it.
Oh, well, Mike, thanks for that. That was, some of the later meters I've seen, some of the Weston ones, but that early stuff is pretty primitive.
Yeah, I've been doing this stuff for so long that people bring things to me, and I get the luxury of them explaining to me what it is that I'm looking at, and then I do a little research after that.
Thanks for the presentation. It was very interesting.
Oh, you're very welcome.
Mike, Ed Melbourne here.
Yeah.
How did they calibrate the early meters?
Well, sometimes things were done with what they called a standard cell. They would have a chemical concoction that they knew would produce whatever voltage, 1 point something, a lot of them were. And then they, you were using shunts and things. So the coil in your meter would have been something that would, they could use that standard voltage in the factory to set it up. And then if it was a big laboratory, they would often, Weston made standard cells probably for 70 or 80 years. Some of them still produce a little voltage. I have a couple of those, but that was the way. You had a chemical standard that you set your meter up, and then by using some kind of resistances, I guess they could make dividing networks so that they know, what the next spot on the dial should come out to be. And Weston expected you to send in your meter every year for calibration.
Thank you.
Mm-hmm.
Hey, Mike, I've got a question.
Yeah.
You said that Edison originally didn't have any way to measure the output of his generators.
Well, there were some complicated machines. They had to actually build a concrete pad that went up to the second floor of the old laboratory to put some of the equipment that they did have. But when they went to the large scale of the lighting system, they put it in Menlo Park. They did it by according to this Francis Jail, by the amount of coal they were using. But the big concrete pad was to steady out the delicate meters they had to work with. One of them was a electrodynamometer, which could measure some of that, and then the rest was scaling things down to use galvanometers with. So like I said, I'm not an expert on that, but that's what I gathered from reading that in the book about the Edison lab.
Okay, is there any relation between when they first started building and using meters to when when 1 volt was defined?
No, I believe that goes back to something even before these meters, more to the chemical reactions in batteries, but I'm not an expert on that. I'm only guessing at that. But I don't think it had to do with meters.
Well, I have a comment on batteries and meters, which dates back from my days in college. When we did experiments in chemistry, one of the things we did was electrochemistry. We needed to measure the voltages that these batteries produced. And we actually had a couple of these standard cells, which were in fact made by the Weston Company. And they were, in National Bureau of Standards calibrated things. And the way this worked is that you had a galvanometer that could be read down to about 10 nanoamps. This was a D'Arsonval meter that was about 2 feet in diameter. And as I say, it was very sensitive. And you had a Wheatstone bridge. And I'm sorry, you didn't have that. You had a potentiometer. You would connect a potentiometer across the battery of interest, and then connect the standard cell to one side of the galvanometer and the potentiometer to the other side, and you'd adjust the knobs on the potentiometer. It had fixed resistors, and you'd set them in and out, and until you got a zero reading, and then that would tell you the voltage. But the interesting thing about this, and it was an actual 1930s, early 1930s device that we still used up into the 60s in college, and it would measure, if you were very careful, to about 5 significant figures, which I find amazing.
Yeah, and you might throw in that a potentiometer wasn't what people think of as a volume control. It was quite a substantial device. Leeds and Northrop was one of the companies that made a lot of those, and yeah, they were not what you would think of as just turning a dial. They had a lot of fixed resistors in it, which I think they did by knowing the diameter of a conductor and then doing the math to say how many ohms that would be in that resistor. So yeah, it was quite an operation. You had better lab equipment than we did.
Well, that how you described it is how they manufactured the resistors. But for these precision devices, they got the precision by doing it by ratios. They would have 3 resistors that were supposedly the same, and they'd measure them. And then by doing calculations, they could figure out what they actually were in the ratios. I don't know exactly how they did it, but it was done by ratioing the resistors.
So we can see basically that having those direct reading meters was a boon to the technology, because all of the things that you had to go back to otherwise and take your reading and check it on a scale, apply a multiplier, and then try to confirm it even with another piece of equipment was quite a chore.
Back when I worked for Motorola and Zenith, the TV engineering, they used electrostatic meters to measure the high voltage. And I don't know if you've ever seen one. They were manufactured by Sensitive Research Instrument Corporation, and if I can share my screen, I'll show you pictures of one. There's the label. Here's what the whole thing looks like. Is that sharing properly?
Yeah, it looks good.
Okay. So this meter box was about the size of a lady's hat box or larger. And this is what the top looks like. And you can see up the back, there's an high voltage insulator that has a rod that goes through it with a knob on the end. And you would set the scale by pulling that rod out or pushing it into a series of click stops that apparently set the distance between the stationary and movable vanes. So here's the calibration on this one, all the way in 6 kilovolts. First click, 10 kilovolts, all the way out 20 kilovolts. And of course, for color sets, we had models that went up to probably 50 kilovolts.
Wow. So Steve, if there's nobody else, we'll give it back to you now.
Thank you, Mike. Very interesting as usual. You make great presentations. Open it up for anybody that wants to talk about anything. Oh, before we do that, somebody reminded me that I forgot to mention the workday we're having on the Friday before the swap meet on the 11th. We've got several people showing up. There are a bunch of projects we want to get done. So if you're available to come help with something, show up anytime Friday. There'll be somebody there all day Friday, starting fairly early in the morning. So open it up to anybody else who wants to talk about anything.
I've got a short subject because it didn't go too well. I had mentioned once that I had seen an ad from Thomas Electronics that they were really specializing in CRT restorations. So I got it in my head that maybe they could be convinced to do 15G P22s. And I finally got someone to talk to me out over there, and it was very short. He just said, "We're not doing TV CRTs." And I said, "Well, there may be a lot that are," and I couldn't even finish the next sentence, and he just cut me off. So I don't know if there'd be any point in trying to say, sending a letter or something saying, we've got 25 of these that could be done, and people would pay X amount of dollars each, so they would gear up for it. But is it worth trying to get a survey of all the members and see how many rebuildable CRTs there are out there and how many people would pay to have it done? Maybe that's something we could do through the newsletter. I'll put a little announcement in there that we're looking for responses from people and see what we get.
I think that's a good idea. It can't hurt.
I'm not too confident, but it's better than not doing anything.
Well, who was the fella at AWA that was involved in that? He's not been with us for a long time now. Jack, in any case, the fellow who was the television guy at AWA for many years, and he had some done, but he said they didn't want to have anything to do with them after a while because it was just too much, and there wasn't enough money in it, even at elevated prices.
Yeah.
There is I have it on good authority. There is a fella in Germany who is doing this. And somebody was just talking about that on Video Karma the other day. It's insanely expensive for the museums to use his services, but most of that I think is shipping costs, because museums have to ship everything as if it was the Mona Lisa. But that's the only place I know that's doing consumer level servicing these days, not military, where they don't ask you what the price is going to be. And I suppose the shipping could be kept under control if we booked enough at one time to send over, up by pallet as opposed to individual boxes. But that's something that could be checked into. I think we were all hoping that Nick was going to be in business by now, but that's still in the works.
Wouldn't the whoever got into that need to also be getting into producing the guns? Because I thought what Nick would be doing, you'd still need to get guns from someplace.
Nick found a source for there's an easy source for replacement cathodes, and Nick was working on using EDM electron machining to be able to cut away the old cathodes and reuse the rest of the gun assembly. But he was trying to put together a poor man's EDM machine. It's not like he has any lab equipment available to him. But that's probably for the long run the best thing to do. But apparently it's pretty tricky. His failure rate was something in the neighborhood of 50%. He also found somebody who was ready, willing, and able to make new guns, and apparently he sent him some engineering samples and they were good. But the problem is the guy's in Russia, and it's a little difficult to do business with Russia these days.
Yeah. Well, maybe just for now, a survey to see, if we came up with a more impressive number that we could throw to somebody, that could certainly bring costs down and get someone's interest up. But so in the next newsletter, I'll put a little survey thing in and see what we can do.
Well, I have a fixable 15GP22 for whatever that's worth.
A lot of us early color collectors can stay more like 6 or 8 or 10 of them, and that's around where I am. Unfortunately, mine all made a trip out to France for that failed experiment, so I got to pay a lot of shipping both ways and never got anything rebuilt.
I have a question to the group. I have a curious item that I wonder if anybody has any experience with it all. I don't know if anybody can see this. It is a Grayburn IF amplifier for your TV set. So it's a little, try to get it in front of my face so you can see the construction. It's a tube base here and a tube socket with a small, well, I can't get it any place where I can see it. Here we go. Little coil here. And you'd put your original IF amplifier, take the tube out, put this thing in, and then put another 6AU6 or whatever the type was in here and you get, several more dB of IF gain. Has anyone had any experience at all with these things? I sort of lucked on it and it's, very odd, odd little piece of thing.
We have one at the museum.
Do you?
Yeah, that I believe we have the instruction sheet for it.
Oh, cool.
If you look online,
Yeah, I'll take a look. I didn't
post-war
know.
accessories. I believe, I'll check while other people are talking, but I'm pretty sure that we have the instruction sheet. I have never seen it in use, but I don't see why it wouldn't work.
Mm-hmm. The leads are sort of long for, 21 or 45 megahertz. I presume it's a 21 megahertz IF, but I don't know. It doesn't actually say on the box any place.
Yeah, I have the instructions for it.
Okay.
You go online, and it uses, it's for 6AG5, 6AU6 or 6BC5.
Okay.
It doesn't say the frequency, the IF frequency.
Does that add a stage or just substitute?
No, it adds a stage.
Adds a stage.
Oh, okay.
Yeah.
Yeah, it's a pretty haywire looking device. The flying here, I presume you connected to ground. Yeah, I'd seen them ads for these things, I remember, in old catalogs, but first time I'd ever come upon one in reality.
Says the blue wire is to be firmly attached to the chassis. The grounding is important.
Okay, yeah, it looks sort of blue.
Well, my suggestion, if you can hear me, is that it has a coil on it, so maybe you can tell what frequency it is with a plain old dip meter.
Yep. Yeah, I got to take it out to where my dip meter is and see what. My guess is it's 21 based on just looking at it. There's not much to it. Certainly, there's very few parts.
How much you paid for it?
Well, like $5.
You can't go wrong.
Can't go wrong, really. That's what I figured. Like I say, I've seen the pictures of them, but had never seen one in reality. Of course, you don't have a TV that would use it, or any way of telling if it worked. Yeah, I'll look that up on the website. See.
Okay.
So the sets that might go into, some of them have only 2-stage IF, and this would make 3.
Mm-hmm. Yeah, that would be what I would think. This probably a month's TV or something like that, or something designed for good, strong signal areas, and you don't happen to be in one. After having bought the cheapest TV you could find. I did find an ad for one, didn't have a brand, in a Lafayette catalog from 1953. And they were selling it, I think, for $3.95 at the time.
I think if it's 53, it has to be 41 megahertz then.
Oh, okay. Yeah, by that time, that's that.
Yeah, right.
But it's odd that it isn't, considering all the old TVs out there still going at that time with 21s, that didn't specify one way or the other.
Yeah, right. I've had a request to repeat the information about the workday. Somebody got cut off during when I was talking about it. It is the Friday before the swap meet, which would be October 11th. I'll be there early by 8 o'clock. And we've got people coming at various times through the day. There are a bunch of projects that need to be done. And we can use all the help we can get. So, and depending upon how many people show up, we'll tackle more or less of what we want to get done. Anybody else got anything to add, or we're going to have an early night?
I see Chuck Conrad in the picture there. He's I'm wondering if his little piece in the newsletter has boosted attendance at the museum yet. No comment, or is this audio off?
Maybe I got it to work this time. Yeah, I'm at the Texas Broadcast Museum right now. We're having an event here with about 80 people. It's a high school reunion or something, and that's why I didn't get in earlier. I haven't heard anything one way or the other about your article, but thank you for posting it. If you want to see what's going on, I can flip the camera around and walk through the museum for a minute.
Sure.
Okay, well, we'll see if we can make that work. I don't know. This is all a mystery using the phone, so we're gonna figure out how to reverse the image. Well, didn't like that.
Did we lose Chuck?
I think I'm back. I'm not real sure. I think maybe it'd be easier to just flip the phone around physically rather than is to figure out how to electronically do it. But this is what's going on in my neck of the woods right now. So we're sitting here in the museum, and we've got, I don't know, about 8 people or something. The class of 1969 from Kilmer High School. They're having their annual, I guess it's a reunion, basically. So they're having fun, at least. I was joined the meeting a little earlier, but that's when they decided to have all their events and stuff, and I seem to be the sound guy. I'm right now in the front room of the museum. Just kind of wander around. We have I Love Lucy is here. Here's our early TV cameras. Here's our Dumont Electronicam. We're really proud of that thing. It's something Jackie Gleason actually came up with the idea of. I think they made 6 of them. We're not real sure. They made a film of their TV show. This is a film chain that actually works. You can turn it on. And you can see a picture up there on the screen. It's actually working. And that's how TV got on. Most of your TV was done. Here's one of the very first videotape machines. Starts here, it goes all the way over to there. This is all one device. It's an Ampex 1000, VR 1000. This thing was about 65 grand back in 1956. Ampex didn't think they were going to sell any of them. They were wrong. This is kind of our most famous camera in the place. It's from KRLD. It was there. Pardon my camera work here, but it was there when Lee Harvey Oswald was shot. I had no idea about that. Bought this camera a long time ago when a museum closed in Dallas. And 20 years later, I found out that it had a little bit of history.
What type is it, Chuck?
It's a GE PE 25 is what they call it, although GE wasn't really all that specific about it. So there's a little trying to get this camera to do something. There's it may be this one in this picture. We know that it was there when Jack Ruby was hauled out in handcuffs. That must have been a fun thing. Here's one of our 2 RCA TK41s, and this one I bought at ETF years ago at one of the auctions, and we've actually made it do something. This one is too far gone to ever work. I don't know if I can get this monitor to come on or not in any time, but we've cheated. This thing, it's missing a lot of parts, but right here is a little screw. Looks like a Phillips head screw. It actually looks more like the Phillips head screw than the one that's a real one over here. This is a TV camera. And it makes a fairly decent picture. It even has a microphone attached to it. It looks like somebody's turned off our time-based corrector. Yeah, it's probably not going to fire up. I don't want to bore people waiting for tubes to warm up. But we also have a large collection of Predictus. And some of them don't blow up. Some do. You know, we all know what fun those are. And a couple of Safaris sitting here. They say it's just like watching a movie theater, but I don't know what kind of movie theater they were watching. That's a whole other story, I guess. And we've got all kinds of early radios and TVs. Hey, there is a picture. It's a god-awful one right at the moment on this monitor. But I can wave it myself here. And it is coming out of this little screw. But the problem is not with the camera. It's actually with the time-based corrector that we have to use to get it to lock up. It's a Conrack monitor. And they're pretty fussy about what they like to see in the way of a video signal. This room is full of early radios and a bunch of TVs. This is really the Express tour. A lot of early TVs. Some of them are connected up and actually work. We like it that way. And I think our most interesting TV, though, for me, is this RCA Berkshire. There weren't many of these made. I think about 240 of them, something like that. It's stupidly expensive. Like, not sure how, it was $3,250 back in 1948, which was, I mean, you could buy a house for that, and we'll see if it'll fire up here. It's a projection TV. And yeah, here comes something. And there we go. have the Kellogg's March on the Howdy Doody show. There's Clarabelle. But it's one of my favorite TVs in the place. But we're always doing something. It's there's a lot of stuff in here, a lot of early radios, microphones. I think my favorite, and tonight might be a good night for it, is this bar radio. Unfortunately, it's missing part of it, but it does have the glassware. So you take this and put your chair next to it, and then use this thing called a Smokerette brand radio. It has a place for your pipes and stuff. You put one of these on each side of your easy chair, and it's the man cave from 1940s. It's perfect. I mean, it's got bourbon and scotch. If your team wins, you can have a little shot, and if they lose, you can have a really big one. So anyway, that's what I did on my summer vacation. I just thought I'd pop in here for a minute because we're live on a Zoom meeting right at the moment. This is Warren Willard, and maybe you can see Warren there. He's one of our co-conspirators here. Warren really likes these things that are made of mahogany and weigh 1 billion pounds. We call that gravitationally enhanced, actually, around here. But anyway, he's a very important guy here, part of our board. And anyway, if you've got any questions, I'd be glad to try and answer them, but I need to get back to my crew of people here that are celebrating whatever it is they're celebrating. So I thought I would drop in on you for a little while. So
Wonderful. I'm glad to finally see part of the museum.
Yeah, well, it's one way to see it. It's kind of awkward, but with cell phone. If I could figure out which button made the picture reverse, it'd be a lot easier. But anyway, you get some idea. And if you'd like to buy a tube, we have them. And tube testers, and lots of other weird stuff. I mean, there's a bunch of stuff in here. It's a little crazy. So, but I really like the nipper that you got at the ETF, much better than ours. Although I like ours, but you got the best one of all. There's no doubt about that. So,
yeah, thanks to Dave Arland, you can't beat that.
Well, that thing is pretty cool. Oh, we even have a 70s room in here. I'll go take you in the 70s room for a second. It has a quadraphonic stereo and an RCA TV, and of course we have a Betamax and VHS machines and a Pioneer, actually a Marantz quadraphonic stereo receiver. And this TV I've never figured out is a Memorex. And I mean, it's a color TV. It's got this red thing. The drugs in the 80s must have been really good. That's all I can figure, because I don't know why you'd buy that, but it is kind of cool in its own way, real weird way. And then and here's our control area this is where our in-house TV channels come from, if we're lucky anyway. So, and then I could take you to the inner sanctums of the break room, but I think I'll pass on that. You wouldn't want to say it's definitely the maid's day off. So, and we have a radio too in the place too. We have a lot of radio stuff, and we're actually building a new studio that's going to have. It's our last bit of ground floor space in the building, and we're converting what was a body shop at one time. This place used to be a car dealership, built in 1949, and anyway, we're converting what was the body shop into a TV studio, and we're being gifted a whole bunch of stuff that's coming in about a week. So I've been painting and cleaning and moving. The room has been a garbage collecting room mostly since we opened about 8 years ago. So it's been a real thrill just cleaning it out. We're trying to make it, putting a lighting grid in the thing, and a control room. converted a bathroom into a control room. It's gonna be cozy in there, but it will work. And that's keeping me off the streets. I can say that. So anyway, I'll send it back to you guys. Everyone have a good evening.
You too, Chuck.
Thanks.
Thank you.
Have a question on the chat. Someone asks, what's the simplest VHF, UHF TV channel receiver circuit out there used in homemade kit type TV sets? Anybody have any insight into that?
VHF, UHF, kit TV.
Yeah, I've never heard of a VHF, UHF kit.
That some of
Except
them
maybe
were-
Heath kits,
Yeah, the Heath kits.
but they weren't simple by any means.
No.
It had black and white and color. I don't know if the black and white had a UHF tuner on it, but other colors did. But they weren't simple at all. Construction, frankly.
Yeah, I would think that most of the anybody who would build a kit in the middle 50s would get a UHF converter module or something like that. Because several TV makers made UHF, built-in UHF tuners, so they had the devices available. But trying to do it yourself, would not be easy back then. Oh, I see on the chat that's Ed Mustafa.
Yeah.
About the sort of circuit you were looking at. A TRF. There were some pre-war ones, I think, like that.
Anybody else have anything to contribute?
You might try a super regenerative circuit. There were super regenerative aircraft radio receiver kits with only a couple transistors that Radio Shack sold. You can make them fairly broad-banded, but it would not provide the kind of performance that you probably want. You try that. They used them for receiving Telstar too before that, or not Telstar, the Sputnik. That would be in the VHF, low VHF range.
I think a regen would be hard to make it wide band enough for television, 6 megahertz bandwidth.
No, not regen, super regen.
Yeah.
Super regen. That's much more broad-banded.
True, yeah. Particularly if you got a separate quench oscillator.
Yeah.
Could work. I don't recall ever having seen anything about that. I think I've seen one build it at home UHF converter, but I think it was back in the days of transistors.
You're going to have to pick the right transistors, of course, too.
Oh, yeah.
Otherwise, a lot of the audio transistors will go up that far, but the gain is unity.
Yeah.
So you're not going to get much out of it.
No, and they, as I remember, it was a Popular Electronics or one of those magazines, and it would have been in the 60s. So the Mesa transistors and so forth would go high enough if you were lucky.
Yeah. Then you're going to have, if you're going back that far, you might be converting germanium to silicon too. Then that's going to be another big problem.
Just a bias difference.
Redesign the circuit and get the bias right. Otherwise, it won't work at all.
Yeah, better to go back to a 6AF4 or something like that. I have a couple of UHF converters from the transistor days that are so simple as to be laughable, but they worked. And one of them, the tuning element, is a rotary switch where they've removed all the detents and the contacts. So they've left one contact, the wiper, and then the half circle or 3/4 circle that was the original carrier for the whole thing turns out to be a tuned line at UHF. And the transistor sits on its full length leads off this converted rotary switch. And that's the oscillator. And then there's a mixer diode that likewise sits on its leads with a insulated wire wrapped around one end of it for the coupling. That's just about the entire circuit.
Was that probably a gimmick capacitor?
Yeah, basically.
Yeah. And then that's another problem when you're getting up into UHF. All the wires that you use are now turning into coils.
Yeah, it's laughably simple. And back when UHF stations are still on the air, I actually plugged it in and the doggone thing worked.
Yeah.
So, amazing. But I don't recall ever having seen anybody try anything like that in the days of tubes.
Yeah, I've heard about the tube UHF converters when they first started transmitting on UHF, and the sets weren't required to have UHF tuners, and people were adding those on, and they apparently didn't work well. I've never seen anything that was particularly good.
Good enough, apparently.
Yeah, there are people that collect those.
Yeah, I've got the world's largest collection. You can see some of it.
Oh, okay.
And the only reason I say that I have the world's largest collection is no one has been crazy enough to say, "Oh no, I've got something more."
I wanted to bring up a different topic, though. I wrote Steve a couple of emails. He asked me this horrible question about a friend of his is putting up a plaque for Charles Francis Jenkins, one of the early, and I wrote him back probably with too much detail, and then sent him a link to a wonderful video because people always want to say who was first with television, and I think that's the wrong question because there were so many people involved. But Mark Shubin has a wonderful video where he goes through the history of television backwards. And he says, some people say that this guy invented such and such, but a year or two before that, there was this guy that he did this. And it shows the antecedents. And you can go back much farther even than he did. He went back 150 years or so. I have a book called The 4,000 Years of Television, which came out in the 40s. It's a wonderful book to show how one thought led to another. similar to that Connections television show that was on for years ago on PBS, James Burke. And I recommend Mark Cuban's video, which is on YouTube, very highly. It's very entertaining, even if you can't watch the whole hour tape. The first 22 minutes or so, where he's doing the backwards history, is fascinating. But on the Jenkins thing, the problem was that the man that Steve knows was going to put on the plaque, Charles F. Jenkins, father of television. Well, you know, as JFK said, success has many fathers, and failure is an orphan. And I think it would be better to say, just use the words Charles F. Jenkins, television pioneer. And of course, people don't know that he had a tremendous number of patents, like 400 patents or something like that. And maybe a quarter of those were on television. And then he also invented all sorts of parts for automobiles and airplanes, because his hobby was flying. And he writes about that in his book about the Portrait of the Young Inventor, or some name like that. It's a fascinating book. But anyway, I think that the answer is to call him a TV pioneer. So, Steve, if you're still listening, that's my suggestion.
Actually, what he wants to put on the plaque is inventor of television, which is even worse.
Yes.
And I just sent him an email pointing out that actually Baird demonstrated, motion television a few months before Jenkins did. So it's really hard to say that Jenkins was the inventor of television. And I suggested what you suggested to him, that he call him a television pioneer. Now, I don't know if he'll do it or not. He seemed really set on I would say dramatizing this thing. I don't know what his goal is, but obviously I have no control of whatever he's planning to do. But I put my 2 cents worth in, and we hope he does something that makes sense. Of course, how many people claim to be the inventor? Do you have people claiming to be the inventor of television? Baird, now Jenkins, Philo, Vladimir, you name it.
Well, it goes back before Nipkow, but he has the master patent, as Albert Abramson said, and they all based their most of the mechanical guys based their work on Nipkow.
Yeah, right.
But even Nipkow's work depended on earlier developments.
Yeah.
So that was Mark Cuban's genius in that video. It's
right.
a wonderful job. But there, more recently, I've learned about this A.M. Lowe guy that was, one of Baird's early displays was at Selfridge's department store. And the thing is, A.M. Lowe did the same type of thing 10 years before Baird. And people don't know that. Not only that, but there's contention over whether Jenkins or Baird was the first one. And, it's silly to say the first, because you're talking about a composite invention. And almost everything in Baird's invention came from somebody else. The scanning mechanisms were all invented in the 19th century, and except for the possible exception of Jenkins' prismatic rings. But all the disc and drum mechanisms came from a century earlier. And then before Baird or Jenkins, you had DeForest inventing the vacuum tube, which made all this possible, and also the phototube. And D. McFarland Moore making the glow tube. And Jenkins had those things, the pickup tube and the glow tube, because he had an association with General Electric. He had those things before Baird. And also, I have in the George Shire's bibliography, which is one of the basic research texts on mechanical television, there's a story of Jenkins making a demonstration in 1923, and Hugo Gernsback was there to watch it. And he wrote it up in his magazine. So that comes into contention with Baird. And that's where you get into the the term true television, which Baird used often, and other people like Gernsback even used it in some of his magazines, to mean different things. But it's a way of restricting television to Baird. But the problem with that is Sarnoff could make the same claim and say, well, the mechanical television wasn't really television. It was true television, uses the Zworykin tube. Farnsworth could say, ah, yes, but I invented sync before you did, and, they get all these silly arguments when you can look all the way back 70 or 80 years before that, and there were precursors. And I don't really draw a distinction between what today we call facsimile, what they called phototelegraphy back then, or telectroscopes, because television can display still pictures, television can display silhouettes. So calling them untrue television is a figure of speech. It's hyperbole. That's a problem. So I mean, Baird was a great promoter and promoted his brand constantly and did a wonderful job of it. But you can't believe all the things that he published or his lieutenants published. It's the way Sarnoff was too. I invented television at the 1939 World's Fair. That's okay in the sense of Sarnoff invented an industry. That may be true, but that's in one sense. It's not. You can't say the whole field of television came from one person. And for another thing, it's still developing. So there's a lot of problems with that, and I'm sure that you understand this, but I'm not sure that your friend that's putting up the plaque does.
Well, actually, he's not my friend. He's just somebody who wrote to me.
Yeah, I've gotten into all sorts of arguments with people that have an axe to grind on this, but there were lots of television people, and not all of them even have stories. Baird was very good at promoting television itself. Most people don't know that Leon Theremin, the guy that invented the musical instrument, was involved in television about the same time in Russia. And there's almost nothing written about it. I've seen like one book on that. And the story on A.M. Lowe, that's only 2 books. So, I mean, there's very little on some of these people, especially enemies of England, like Germany and Russia. There's very little written on Manfred von Arden, for example. But Theremin, there's many others. Farnsworth wasn't the first image dissector. Most people don't know that. They had one in Germany a year before Farnsworth, but Farnsworth's worked. The other one, it didn't quite come up to working, but they used those patents later in Europe to make an amplified iconoscope, which we couldn't do here in the US. They had one, but because of the patents interference between RCA and Farnsworth, they got into this big kerfuffle. But the Germans said, oh, we have this Dietzken patent. We can use that, and we can go ahead with this amplified iconoscope. And then, of course, we came out with the I/O, and that blew that away. It was much better. But it combined Zworykin's work and Farnsworth's work with the image multiplier. So I know a lot more than you needed to hear about. Much of what you already know.
Thanks. It's really informative.
I was just watching a YouTube video earlier today. I haven't finished watching it. Somebody's claiming that Ernest O. Lawrence, the nuclear genius, worked on the Manhattan Project, was one of the inventors of color TV. Now
yes.
that I'd never heard before. So
it's true. Yeah,
it's true.
Okay. Yeah. That video you're mentioning came from an apparently young and naive creator who's working for IEEE Spectrum magazine. And yeah, there were a lot of comments that her write-up was very spotty. and fell into that trap of Mr. X invented TV, and she she mentioned some of the contributors, I think, like Philco, but at the same time missed out on a lot of others that were involved in NTSC color, and she specifically points to the IRE proceedings, the issue that's all about color TV, and points out Lawrence's paper, and then fails to mention how many papers came from other organizations and authors. So there's been a lot of critical comments on that video.
Lawrence, I was going to say, Lawrence kind of thought of television as a hobby for him. And that tube that eventually various other companies developed, the one that was the most interested in it was a little company called Sony. And they actually manufactured a few of these chromatron tubes that were based on Lawrence's design. They couldn't get them to work properly, so there was a lot of fallout, and they wound up losing money on each one that they sold. So they had a guy there that developed a modified version of that, and they decided to call it the Trinitron.
Yeah.
And if you have one of those sets, the original Lawrence version from Sony, I would imagine that's probably worth quite a bit of money now.
Yeah. In the comments on that video, there's one fellow who's been commenting on a lot of videos about early color, complaining that it was invented by a Mexican inventor. And
Camarena. That's Camarena.
Yes, Camarena. And of course, it's another case of Mr. X is not the inventor. And there's actually the most complete information I've seen is on a page on an early television site. It includes a lot of information about his career and all the things that he did do. One of the things that had been cited previously about him and comments about him inventing color TV cited a two-color system that he proposed, which when he proposed it was absolutely nothing new. It was totally based on previous work on field sequential systems and so forth. And he was proposing it only as something that would be more economically feasible than a three-color system.
Yeah, there was an article in Radio Electronics that Cliff Benham sent me a long time ago that just detailed that two-color system, and I was very interested in that. I have a couple of web pages on two color sets, and yeah, he was a developer of that. The guy was brilliant. He was working on regular field sequential three-color television in the early 40s, and I think he beat one of the patents. I think he beat Goldmark's patent by a month or two. DeForest was also working on it, and of course Baird. So I mean, and RCA had their version of it, and that was before they came up with the three-color simultaneous system.
The fellow who built the two-color camera that was featured in the Popular Electronics was at one of our early television conventions a number of years ago. He brought the camera to show us. That was pretty fascinating.
Yeah, Gary something.
Yeah, the actually that work goes back to photography. Polaroid spent a lot of time working on color photography. When I was a kid, I experimented with it. I thought it was fascinating, so I bought some filters and started playing around with it. And it does a pretty decent job of producing most colors, but it's sure not full color.
Yeah, well, it also goes back to color motion pictures. Technicolor developed a two-color system prior to their three-color system. And the interesting thing about a subtractive system like that using dyes is the two colors do not have to be complementary exactly, because when both dyes are absent, you get white, whereas you're much more constrained in a television system. The two colors have to add up to white, or the color balance of the whole scene will be wrong. So if you look at any of those two-color Technicolor films, which still exist, typically the dark grays look brownish, and which is just fine for making a picture with natural objects, trees and faces and stuff like that.
Yeah, the Cinecolor picked up some of those. I think it was inherited a lot of the ideas from Kinemacolor, which was earlier than that, two colors. And they were releasing Cinecolor films into the 1950s. Abbott and Costello made a couple of those. Captain Kidd was Cinecolor, and I think there was one called Invaders from Mars. It was another one that they made. Yeah, they have to very carefully design those things. So there are also a couple of TV tubes. Of course, Baird made the Telechrome, which was a two-color tube, and he had a three-color version, but he never actually displayed it or built it, as far as I can tell. I don't think it would have worked. But in the 1960s, I think it was the 60s or the late 50s, there was a guy named Shanafelt. And there's an article on that in one of those, I don't know if it was Popular Electronics or Radio Electronics. And that was an interesting flat CRT. You could look on the front or the back of the tube and get pictures. And they have a cover picture on this magazine with Johnny Carson on there in two color. But it's a very restricted palette. And it was all he needed for the picture of that portrait. But obviously, if they show other things, the sky isn't blue, it's cyan. And the grass isn't green, it's cyan, for example. Of course, real grass isn't green all the time, except in ads for Scott's Turf Builder or something. So you can get away with certain modification, but you start to notice that certain combinations wind up looking gray. If you're combining the two colors and you're like 50-50 or something, it looks gray. So you have fewer colors, and it's very obvious when you don't have that. It's like 3 points make up a plane and 2 points make up a line, and that's the situation you're into. You have only what's you can go up in red or up in cyan, but if you have 50-50, you get these gray colors that look muddy. There's a wonderful site, a website on the film version of that, comparing Cinecolor to Technicolor. And they show, I think it was the film The Robe, and they say, this is the way it looked on the screen, and this is the way it would have looked if it were in two colors. And they show the togas that various actors are wearing, Richard Burton and some of the others. And the color is very plainly off. The thing is, if you don't have a comparison for that, many times you can get away with it. If you have a female model walking on the screen and she's displaying a dress of a certain color, though, you're going to get in big trouble. Or if the background is gray when it should be some purple color or something like that.
Yeah, when the first full length, popular 3-color Technicolor movie came out, the critics complained that they could make true blue and yellow, that the production just leaned on it too hard. They tried to get blue or yellow in every scene.
I think that's the reason why every once in a while they do an experiment on television with 3D. And they used to have, when they were doing the glasses, the colored glasses, before the Polaroid glasses, they had the anaglyphic glasses, and they'd always have red and cyan, or some of them used red and blue, which wasn't as good. And you'd get a pretty good black and white out of that, but not much color. So recently they went to glasses that were blue and yellow, which obviously, if you were using those colors with television, you wouldn't get very good separation because there's a heck of a lot of yellow in most pictures, but not very much blue. But because of that, if you're getting rid of blue and yellow, you can still get lots of other colors. And I think that's why they switched from the cyan and red to the blue and yellow, because then they could get 3D with some color instead of just black and white. It's pretty clever.
Hey, I'm going to have to drop off. I've got an early morning flight and I still got to pack. So everybody else keep talking as long as you want to, and we'll see you next month.
Good night, Steve.
Night.
Hey guys, you were talking about Cinecolor, the 2-color process for movies. Well, Popular Science had a series of shorts in the 1930s that were made in Cinecolor, and one of them featured Philo Farnsworth demonstrating television. Would you like to know more detail about that? I've been Googling it as you've been talking. I found it on YouTube. You want the link?
Oh, yeah. Yeah.
Okay. So this is Philo Farnsworth.
Can you write it in the chat?
This is Philo Farnsworth demonstrating his TV system. I think it was in the 1930s at the Franklin Institute in Philadelphia, and it was filmed in 2-color Cinecolor, and it went into the theaters. Do you want to? I can just. It's on YouTube. I can give you a link, or I can bring it up, and we can watch it together.
Well, can you write the link in the chat window?
Yeah, I'll do that right now.
Thank you.
Yeah, I've been Googling it while you're talking about it because I remember seeing it. And yeah, there it is. I'll click on the YouTube link and I will put that in the chat. Where do we have it there? There we have it there. Cinecolor movie about Farnsworth. I'm typing away here. And there's the link. Okay.
Thank you.
You're welcome.
Another thing about the Cinecolor was they had trouble with some projectors because Cinecolor didn't use a black variable area soundtrack. It used cyan, and they had to get that solid enough so that the sound projectors could use that. And I think these Popular Science films were on 16 millimeter too, if I remember right.
Yeah, they were originally filmed in 35 millimeter.
Oh.
And they had a camera with with 2 rolls of film in it. that shot the two, and I think the colors were kind of cyan and a brownish. They were able to combine, you know, if with both of the dyes present, they combined to black, and with none of them, they opened up to white. And they were pretty good with flesh tones, skies, and grass, but they didn't get the others range of the colors.
I think Cinecolor might have even coated both sides of the film, one with one for each color.
Yeah, something like that.
So what you try to focus that, it's not going to be perfect. It's one of them's going to be fuzzy, or else you're going to have an average.
Mm-hmm. Yeah, I don't remember all of those details, but there, there were a lot of different attempts at making color movies in the 30s, which included like gluing two pieces together, and they had all kinds of problems. But the 3-color was perfected by Technicolor in 1935.
Hello.
Okay, you got the link, so you can watch it when you like. But it's kind of cool that the Farnsworth was in Cinecolor.
So what was the advantage of these 2-color systems, just to try to make it things simpler and cheaper?
You got it.
Yeah.
Okay.
Yeah.
And they didn't quite pan out then. Yeah.
Well, people recognize shortcomings, of not having a full range of views, and so there was always a desire to improve. But when you look at what it took to shoot, develop, and print a Technicolor film, it's just amazing that they could get it to work, because everything had to be so precisely controlled. Not only the first things that you would think of is the relative exposure of the red, green, and blue spectra, but then the printing to the same contrast, development to the same contrast, and then the printing was by means of creating intermediates that would absorb an amount of colored dye according to the original negative. And that stage was very sensitive to the chemistry of the dye bath. What was the pH? What was the temperature? What was the concentration? And Technicolor Corporation would not license anyone to do it except themselves, because they rightly figured that nobody could control the process as well as they could, and they didn't want inferior results going out to the public. But the processing plant was a long series of paths of, developer and dies and the printing from the clear gelatin that had soaked up the dye onto the final print stock. And the way they controlled it is not only having instruments for temperature and measuring the pH of the solutions and all that, but they had an intercom system with stations all along the process line. So if it went so far and at some point the film was not coming out right, somebody could pick up the intercom and say, "We've got a problem."
Yeah, some of these early Technicolor films, you'll see this lady's name on the front. Kalmus is her name, and she was supposed to be the honcho that was in charge of all this, and the rigid procedures.
Yeah, well, she was the inventor's wife, and she stuck herself into the company. She was self-titled as the chief color consultant. And so she stuck her nose not only into technical issues to the point that she could, with what knowledge she had, which was not that technical, but she also demanded certain things of set and costume design and so forth, some of which had a good technical basis because the process was very contrasty and you needed to control the light ratios and so forth, but some of which was just her aesthetic judgment, which drove directors crazy to the point where some of them managed to be producing films out of the country while she was in the US or vice versa, so they could avoid her. And the other thing that wasn't known at the time is early on in the three-color business, she divorced, and that was never revealed publicly to everybody Technicolor dealt with. They thought she was still the owner's wife.
Wayne, did you ever know Arthur Brownwell?
Not sure. The name only sounds vaguely familiar.
Yeah, my parents bought a house from him way back in the mid-50s. And I grew up there, and except for the first couple of years. And Arthur was a professor of electrical engineering at Northwestern University, a very prominent guy there. And he patented his own system of color television with a special picture tube that put color phosphors on 3 grids. And I don't know beyond that. I've read parts of the patent, but I don't know exactly how it worked. But obviously, it wasn't one of the choices. But
Brownwell.
Brownwell. I found out years later that he was involved in. I was talking to Bronwell, and he would be in his hundreds now.
Wow.
Yeah,
Brownwell.
Yeah, but no, he's got a W in there. It's Bronwell.
Oh, Brownwell.
Brownwell, yeah, and must have been a very interesting guy. Of course, I was only a little kid when I met him, but I found out years later he was involved in color television and apparently was well known among some of the people in the industry. I was talking to a guy that had worked for Sanabria and Muntz in the 1950s, and he knew this guy pretty well. Hugh Christian was his name. He's dead now too.
No, I definitely don't know him.
Yeah, he's in.
What tickled my brain is I knew a woman named Bronwyn Jones, I think was the last name, who worked at CBS Labs. But that just the sound of the name sounded a little familiar, but that's all.
Yeah, well, there's lots of people involved in television, of course. Yeah, Arthur Albert Abramson's second book, the one that they released posthumously about the 1940s and about videotape and all that, mentions him, Brownwell, in passing. And I said, I'll be darned, that's the same guy.
I'll have to look that up. You say it had something with phosphors on grids.
On the grids, yeah. Yeah.
That's the first I've heard of it.
Yeah, I can't imagine that would be quite as effective as putting them on the face of the tube, but then crazier things have have happened. I mean, the telechrome tube that Baird released is, I think, really nutty. It's really two vacuum tubes that they just glued together in the middle in his patent, but then they found out that they couldn't produce it that way because it would explode, it would implode immediately. So they got a rectifier tube that they would normally use for theatrical lighting or railroads. It was a giant bulbous tube, and they put a transparent electrode in the middle, and then two necks on the thing at 45-degree angles that shot at the two screens, and then you could see the picture by looking through the front electrode onto the back electrode. So you're essentially looking at two tubes, and I think that would be terribly difficult to produce and sell. Plus, you'd have to see the picture by looking through the tube, which was a bulb-shaped tube, and the picture appeared in the middle. And I came out of the games industry where we had a game that was bulbous like that. It had a tendency for the bulb to form a meniscus lens and distort the image. So that was built into the tube. Plus, it had no DAG coating on it. So any other lights that were inside the set, like all the tubes, would get into the picture. So there were some severe problems. And then double filaments, and it had a third, because the thing was like a light bulb, it had a third thing that looked like a neck hanging down. Probably the filament went in there or something. You know, I figured all this out one time when I was working on the page, and I don't have all the details in front of me, but it was crazy. And then he wanted to add yet another neck to the tube and corrugate one of the plates, so that one side of the corrugation would be one color and the other side would be the other color, and feed that in from yet another angle. And of course, you had to have ways of correcting all these three things, because they would have terrible distortion of the image. So that one I don't think ever built. Yeah, so the Brownwell tube next to that would be very simple.
I wonder about the details of the Brownwell. You know, the Lawrence tube used high voltage grid switching to deflect the beam to one phosphor or the other. And so I wonder if the Brownwell tube was actually somehow deflecting the beam to land on one set of grids or the other.
I don't remember how he did that. I think I read the patent, but it was years ago. And yeah, I remember that Lawrence's tube had trouble with RF radiation.
Yeah.
And that caused a lot of problems. And then they came up with the Apple tube, which was supposed to be an improvement by using the photomultiplier that was part of the tube. And that one failed too. But they had some kind, I think the Apple tube turned into Uniray, if I remember right, in the early 70s. But another company bought it out, bought out Philco. But Lawrence's tube, nobody could seem to get that right, except that they, for an enormous amount of money, Sony produced some of them, and that was after Paramount gave up on it.
Mm-hmm.
So that was it was a fascinating experiment, but to Lawrence, apparently, it was just an interesting hobby. I don't know, maybe that grew out of his work with the accelerators, because a guy that I knew that worked at Fermilab told me once, I don't understand all of the what goes into an accelerator, but he said, an accelerator in some ways is like a giant CRT with the accelerator electrodes and so on. And I said, oh, how would I know? But it's an interesting idea. Maybe there's some relationship there in Lawrence's mind.
Well, it just it doesn't necessarily have to be so. It's just that he's got the basic physics knowledge and went through some thought experiments about, could we deflect the beam to the right phosphor, and went from there.
Of course, he achieved, without the shadow mask, he achieved a much brighter picture, and they only used one gun. So I mean that those things would be advantages to it.
Yeah.
I think it might have also influenced the GE Portacolor, perhaps, with the first vertical stripes instead of shadow mask and dots.
Yeah. Yeah, and like most things you look at from history and the outside, I'm sure there were a ton of complications that aren't apparent. That just deflecting the beam left to right is not enough if it gets defocused and hits multiple phosphors at once, and they had to consider that, especially since the switching grid was supposed to be mostly transparent. That means that you couldn't count on shadow mask effects to keep the purity. You had to have some focusing of the beam after it passed through the grids.
Yeah, I imagine you'd have to have adjustments when the beam got onto the extreme angles.
Yeah.
Wow. I'm glad I don't have to figure that out. On the other hand, think of the complexity that the geniuses at all those companies that develop CRTs, that all the complexity they eliminated by having everything operate from one neck versus having we're almost back to having millions of wires going to pixels now. You can matrix them, but there's a limit we've increased the complexity of the tube because we're able to do that today. But for years they managed to do it with very simple systems, and I have great respect for their engineering prowess.
Yeah, I just wish there was somebody who could tell me a sure fix for the white field purity in my 21 AXP22. The lower left corner is greenish or yellowish compared to the rest of the screen, and the individual field purity is just fine. So, but that's a problem that they fought until they came up with the negative guard band tubes with the black matrix.
Black matrix was a beautiful idea, and it's counterintuitive too. It just what a clever idea.
Yeah.
Yeah, that was. Do you know the person that invented that? That was brilliant.
No, I don't, but I can think of a couple of people at Zenith whose names I can't remember at the moment, but I can picture them.
Yeah, that must have been a thrill to see when it finally started working.
Yeah. And of course, the first thing that happened was that there were all kinds of lawsuits about advertising. You can't say that it's brighter than ours, or you can't say that it's got more contrast and so forth. And it went through, it went to trial. A lot of the advertising did, and including setting up demonstrations of the older tube and the newer one, and so forth.
Some of these things are just subjective, but that's important because that's going to sell sets.
Yeah. The point is, if it's measurable and it can be seen under controlled conditions, then you've got something. But if it's measurable, but most people can't see it, you set yourself up for a lawsuit. And that reminds me of when Zenith brought out their Color Sentry circuitry, and they wanted to advertise that it adjusts the picture automatically. And so I got a call one day from the advertising department, and the guy wanted to know, can we say that it adjusts the picture 30 times a second? And I said, well, the way the circuitry works, it's practically instantaneous. So you could say it adjusts the picture 15,000 times a second. He says, oh, that's fine, but I think we'll go with 30 so that we don't attract lawsuits.
This is the kind of stuff that I remember arguments like this when I was in the audio industry. And I was working at the ad agency for Shure Brothers, and they were constantly talking about trackability, which was something that they invented, but it was measurable. You get back to the problem of, well, yeah, but can you hear it? And then record wear too. It affected record wear, and then they had an added thing that they added to their cartridge to get rid of subsonic resonance. And People said, why do we care about that? Well, they had a demonstration for that. They had a disc that went into subsonic resonance, and the cartridge, the Armin cartridge, turned into a woodpecker and destroyed the record. That was effective. That was effective. But yeah, a lot of this stuff is the impact on the customer, and you have to demonstrate it a certain way. Then you have to convince the customer, if he's not naive, that demonstration is valid to his own listening experience or viewing experience. It's like the time when I was at Consumer Electronics Show in Chicago, and Sony was showing its early high definition television, which was analog. And they had two beautiful Sony sets next to each other. One was their best 25-inch color set, and it was in perfect adjustment, of course. And then next to that was its the proposed high definition set, which was, like a $50,000 set. And if you watched them, they had it up so that it was a certain distance away from the wall. And you would, most of the time, the customers would be fascinated, and they would look right up at the set. And they could say, oh my goodness, you can see the goldfish on the 25-inch sets. You can see their fins, but on the high definition set, you can see the air bubbles coming out of their mouths, and you can see the depth of the picture. And I said, I'm going to put this to a more critical test. I backed myself up to the wall, and I said, this is about where I usually view the set from. And then they look the same. And I said, well, for the $500 that the 25-inch set costs versus the $50,000 that the other ones cost, I think I'll buy the $500 set,
That's the Lechner distance, phrase coined by Mark Shubin.
Yeah, a lot of these parameters, people don't believe me, but I tell them, RCA did all this research back in the 1930s about, what the best detail was for a given viewing distance. And despite the fact that technology has advanced, the human eye hasn't changed much in that amount of time.
Yeah, that reminds me, I've often wondered what the Lechner distance is in Japan. The Lechner distance is based on the average U.S. living room, and the distance from the chairs to the TV.
Yeah, I think what changed a lot of this stuff is computers, because people are used to looking at the screen much closer than they were back in the days of living room TVs. And also another thing is projection TV changed it too. In the bigger picture, they want more detail. Oh, that reminds me, the Advent projection sets, that were everywhere in the 1980s and 70s. They originally had the three projection CRTs, and then they went to another system that had only two. And I'm thinking that was a two-color system. Do you know if that's true?
No, there were no home. Well, maybe I'm wrong, but I don't think there were any home systems that used two. The GE Talaria projector, which used an oil film, and what is the big three-color one from Europe? I can't think of the name. But
Ida 4.
Ida 4, thank you. GE came out with a version that used two tubes, but they actually were able to control both red and blue with a single tube. So it looked like a magenta and green combination, but it was actually green on one tube and red and blue on the other. I don't think at that era, anybody produced a two-color system.
Thank you.
Yeah, it was. Speaking of technological developments that are now irrelevant, those home rear projectors with the 3 tubes, they had lens systems with ridiculously low F numbers, like 0.9 and so forth. And there were vast improvements made in the lenses, some of which involved simple baffling because the aberrations and scattered light would come from the fact that the phosphors on the tubes emit light in all directions, and light that came from the left side of the picture would be much better focused by the left side of the optics than if it went off at an angle and went into the right side of the optics and then tried to be focused. So one of the things that they came up with is putting baffle vanes in the, so they have a vertical vane and a horizontal vane that would stop light from the tube going diagonally across to the other side of the lens. And that was actually a big improvement at one point. And then, of course, there was just an awful lot of research on the non-spherical optics, and which could be done with plastic lenses and not easily at all with glass. And that helped a lot. But I had a series of Zenith rear projos at home for home observation, and over the years, the contrast ratio on bright scenes improved dramatically. The early ones always look foggy because of the stray scattered light, and they never got as good as a direct view CRT, but they improved quite dramatically.
Well, probably the screen's improved as well.
Oh, yeah. And there was a lot of improvement in the screens in terms of making the cabinets shallower, because they came up with prismatic components that had high refraction index, so the light could come in at a steeper angle, and then at some point the rear projectors. I have a digital mirror Mitsubishi that's been my HDTV TV since the early 2000s, and it's got a very shallow cabinet and a very steep approach of the light to the screen. And the way they get away with that is they have a lenticular sheet, a prismatic sheet, I should say, that has total internal reflection. So the light comes in, reflects off the inside of the prism elements backward, and then off the back of those elements and straight out the screen to your eyeballs. So it's a double reflection just within the thickness of that screen.
Wow.
So I think the whole set is about 8 inches deep, which was, this is when the goal was to match the thickness of LCDs. But when I bought this Mitsubishi, the 65-inch screen was $1,000, and 65-inch LCDs were about $3,500.
And it's mechanical from what you said.
And it's got that filter disc that runs at 3 or 4 times NTSC field rate, and when you turn the thing on, you can hear it spin up. Well, I think I'm running out of steam, and besides, I want to go and watch some of these videos. So, good night, all.
Good night, Wayne.